Hello, my name is Juan Esteban Castrillon. My name is Andres Felipe Monsalve. We're from the city of Medellin. We attend to José María Bernal High School, and Ruta N is accompanying us on our research process. Okay, our project is called the Green Synthesis in Silver Nanoparticles from extracts such as coffee, ginger, aloe vera, and dragon fruit. So, our question is, what will be the most effective method for the synthesis of silver nanoparticles from green reducing agents? Our general objective is to determine a procedure to obtain higher quality and quantity of nanoparticles by means of nature reducing agents. We have three specific objectives with which we rely on to carry out our research. One of them is to determine which is the most effective procedure. Another is to determine which materials are most effective for the synthesis. And the third is to determine how the variables of concentration, time, pH, and temperature are related to the quality and quantity of nanoparticles obtained. Our research is based on an investigator from the National University of Medellin called Cardenio Calle that proposes a way to synthesize nanoparticles of silver from a garlic extract. Okay, our project is based on 4 steps. This is coffee grown in Antioquia. The coffee they sell is grains, but we got it toasted and ground. This is dissolved at a ratio of 30 to 1. For each gram of this extract, we added 30 milliliters of water. Then it is taken to liquefy. Then it is packaged again and heated with the help of magnetic stirrers. Then it is put to filter. Okay, this is phase 2, the preparation of the metallic precursor. In this case, it's silver nitrate, which is prepared in 0.01 molar in 100 milliliters of distilled water. It is stored in special conditions since it is photosensitive and exposure to light will cause it to oxidize. This is phase 3. Basically, what is done in this phase is the synthesis of nanoparticles. We proceed by doing the following. We mix the metal precursor and the reducing agent at a ratio of 3 to 1. 3 milliliters of metal precursor and the millimeter of the reducing agent. Then what is done with the solution is to raise the pH to a basic pH by sodium hydroxide. The next thing to do is to take the solution to the water bath in a magnetic stirrer with iron. Then we put the small beaker in a bigger one for we can control the temperature in a more appropriate way. Then you have to heat the solution to 60 degrees, keeping the stirrers on for 3 hours. Since time is a variable we can change to see the results. Okay, this is stage 4. In this phase, we take the samples packaged like this and send to a company called Psychotech. In this company, they provide us with details on said samples. Well, in our case, we use a technique called nanotracking, which consists of a device by means of lasers capturing Brownian movement of the particles. And the results arrive in a graph. In this graph, you can appreciate the concentration and the size of the nanoparticles, and from this is what we read the results on. To finish, I will present the results and conclusions of our project.
As our first result, we obtained that the smallest size of nanoparticles was made by the aloe vera, which was 82 nanometers. As second result, we obtained that when we change the pH, the size of the nanoparticles is affected. As third result, we obtained that the ginger extract gave us a size of 100 nanometers, and it was one of the best results we had. As our last result, we obtained that when using the extract of guava, we did not obtain such satisfying results, since maximum peaks in the scale of microns were observed. When I say maximum peaks, I refer to this graphic right here. As a conclusion to the project, we obtained that the aloe vera extract was the one that gave us the best results, with a size of 82 and 463 nanometers. As second result, the general size of nanoparticles that we obtained in our project was between 82 and 917 nanometers. And as third result, the synthesis of nanoparticles using only natural extracts can be better than the chemical synthesis because it has the advantage that it doesn't leave any bad residues for the environment. And finally, as the most important conclusion of our project, when choosing the extracts, we verify they present antioxidant characteristics, since they give us to understand how much thiolase, phenols, and carboxylates, which favor the stability of the metal nanostructures. During the realization of the synthesis assembly, we had all the safety measures. We have been in a research process for 5 years in the field of science applied in chemistry. And in this project, we are already going to fulfill our third year of work. For our group, it's a real pleasure that people like you are listening to us, especially on this project that has marked us so much. Thank you very much.